Have I killed it? Sorry. Technology. Sorry. Oh, thank you. Thank you. Sorry for. So I will be more careful with the pointer. On the left ring, I have shown that in the city with its suburbs, different means of downtown transport can be developed over the time by historic development. And of course, normally they are not integrated with each other. And in order to reach the suburbs or the region, at the end of the suburb, or at the border of the suburb, you will have again to transfer to other means of transport. Downtown, this may be BRT, tram, LRT, metro, depending on the capacities required. And a solution to provide seamless, integrated traffic would be a collection or a direct line from the region through the city and again to the region. This would be what we in Germany understand as S-Bahn, which is, so to say, CPT or the Supervia, passing directly through downtown Sao Paulo or passing directly through downtown Rio. This would be the idea. I call it a bundle, which means the lines from outside, let's say they have an interval of 10 minutes, and we have 5 lines from that side, 5 lines from that side, that would provide a 2 minutes headway downtown. And so it would be a kind of metro downtown, high capacity, and it would provide a seamless transport from the outskirts directly to downtown. Of course, what I haven't shown here is afterwards to have the subsidiary network of buses, train, subway, or whatsoever. So my presentation will now go to show that for this solution, new technologies are available to improve or to provide seamless transport from the outskirts to downtown and back to the outskirts. Just for definition, there is, according to our German understanding, we have, in terms of rail-bound systems, we have the tramways, which share the traffic space with the road traffic. That's why we have a limitation of 2.4 meters in width and 75 meters in length, but this is a question of legislation in the country, normally low floor. We have what we call LRT, high floor with high platforms, mostly separate right of way, vehicle envelope and length of vehicle may be independent from road legislation, and signaling priority at interchanges with road traffic. So here you would see a wider vehicle. And then we have the completely entirely separate rail-bound transport system. This would be the metro, where you have, it may be elevated, underground, or at grade, but totally encaged. I have a few examples here. This one is the recent tramway in Rio. This one is a modern tramway in Frankfurt. You see it shares the road space, and of course this restricts the speed. And we would have something like LRT, also Frankfurt case, with a wider body, a longer train, but still having level crossings, interchanges with road traffic, which would, of course, interfere or reduce the speed, the commercial speed. Then we have the metro here, and this example again from Rio, what we would call a commuter, or in Germany, an S-Bahn. So as we have seen, the Supervia in Rio de Janeiro is a suburban commuter express. It is compatible with railways to a certain extent, I understand, and it is sharing infrastructure with existing railways. So I'm not sure of the Rio case exactly, but in Germany, the S-Bahn or the suburban train uses main line of DB. If there is spare capacity, it uses railway land for depot and maintenance facilities, but it has its own right of way in downtown. So, and also, of course, power supply signaling is all compatible and linked to the federal railways. CPTM in Sao Paulo, Tram Supervia in Rio de Janeiro would be considered in this regard as a suburban commuter only. If the commuter train has a tunnel or elevated track crossing the city with short station-to-station distances, we would have an S-Bahn with the metro function in downtown area. And this could be an own tunnel, like in Hamburg, we will see it later, or, like we will see also during the later show, an S-Bahn, which has a metro operating pattern, and even LRT and tram. This is the most recent development in smaller cities like Karlsruhe, Kassel, Chemnitz, Saarbrücken, and in France, I think Mulhouse. So this is the new technology about which we will talk as the presentation goes on. Other guided systems are less easy to integrate if we talk about seamless transport. For instance, we have the rubber-tired metro system in Paris. This is not compatible with any of other rail systems. We have monorail here. It's difficult to see, but this is this very specific case in Chongqing, where you have a very complicated topography, and I think under such conditions, the monorail monotrillo is maybe justified, but it is a very special case. And of course, also one must point out that VLT Rio is not a standard solution. It is a proprietary solution. A supplier has developed a certain technology, when the operator will always be dependent on this technology. It can't be easily linked into other existing railway techniques, except if you forget about this propulsion system. I don't need to talk anymore about buses. So I have here a synopsis that shows the capacities. I think now I should shortly come back to the buses. You see the capacities here on a single BRT line and a double BRT line. We would have capacities about 10 to 20,000 passengers per hour in direction. And the width of the infrastructure would be between 12 and 14 meters. Station length, according to the effect I showed before, is 90 to 135 meters. If we go for the same capacity, more or less, say, a little bit higher capacity, on rail-bound systems, tram or LRT, we would have 6 meter or 8 meter width of the infrastructure and station lengths, maximum 80 to 100 meters. So in the urban space, in the urban environment, the space requirement is much less. All this in the red here is rail-bound, and that's what we will discuss further on. The examples which I will present right now are first Frankfurt. Its population, 5 million, is not Frankfurt. That is the catchment area of the Transport Association, RMV. This is a tariff and transport organization which has a flat, no, not a flat, a single transport fare, providing the area of South Hesse. There we have a S-Bahn of 300 kilometers, and this S-Bahn covers about 30% of the passenger volume, of the daily passenger volume. We'll later talk about Karlsruhe, again, a much bigger network, 663 kilometers S-Bahn, and the share is about 60% of the passenger volume. Last not least, we'll talk about Hamburg. This is a much smaller network, 230 kilometers. Also the urban space is rather limited, and it has 35% of the transport capacities. The S-Bahn has 35% of the transport capacities. This is the network map of Frankfurt. You see here, downtown, the tunnel, where all the lines which come from the out of the region are running into the tunnel. This is actually a 6 kilometers long downtown tunnel. And all the lines run from the one side in. No, this one stops there, but this one would go down here, cross all the city, and go out, I think here, to the city like Wiesbaden, Mainz or Wiesbaden. This would be Darmstadt. So you have downtown, station distance of 1 kilometer, headway of 2 minutes, 11 terminal stations at the outside, 100 immediate stations along the line, 140 kilometers maximum speed, and station to station distance about 10 kilometers. And the entire network is operated on the power supply system of Deutsche Bahn, of DB, which is high voltage 15 kV, 16.7 cycles. So the trains are compatible with the entire DB network. But in case, for instance here, where the capacity of the DB network does not allow any more additional trains parallel to the existing railway line, successively they have started to build exclusive lines for the S-Bahn. But this is a process which can take place over years, even though the project, the system is available at very short. The only thing you needed to do is this tunnel, and the rest of the network was existing. But this is when the train takes the same power supply as the railway. You see here the typical Frankfurt S-Bahn train. This is completely compatible with long-distance trains. It uses mainline track here. It goes downtown, and you have a cross-platform transfer to the Frankfurt metro system. So this is a physical integration which would reduce your transit time substantially instead of having long walking distances to another station. Now there is one technical slide for the engineers. Recent technology has allowed, and the technology, the technology known as three-phase traction motors has allowed to have on board the rolling stock a rectifier, intermediate continuous circuit, and inverter. So this type of equipment, electronic, can accommodate either from a catenary high voltage going down through the transformer, coming in as AC, being equalized and going out as three-phase AC with variable frequency to the traction motor. But in here in between, you can also feed in from either third rail or from catenary any DC power supply. So that means this train, which is equipped with this type of equipment, and all the modern subways have, as you know, this type of traction converter, three-phase traction motors. That's what you have nowadays. So you can easily design or specify your new trains such that they can pick up DC or AC. And this is, I think, the solution to integrate different railway systems as long as they have the same standard or broad gauge. This is the example of the area Karlsruhe, who actually invented, I must say, or they started developing this type of integration. You see the area which is pictured here covers quite a big part of Germany. And all these lines which are marked with this triangle are railway lines. And those lines which are inside the green circle are old tram lines. And even the city of Heilbronn out here is now connected with its old DC power supply in downtown, but coming out of downtown goes out to the mainline railway, comes out here, switches over, and goes under AC, long distance, on federal railways, and comes into the urban area again on DC. So a seamless transport from downtown, you will see the pictures, from downtown Karlsruhe to downtown, for instance, Heilbronn. You see, this is in distance, the total system, north, south, east, west, about 160 kilometers. Quite impressive. And the thing is, if you, for instance, take a train here, go out on the main line, you don't even realize it. But you will see German high-speed trains next to the tramway of Karlsruhe. So we have a separated right-of-way on the approach roads to Karlsruhe. The train goes to the pedestrian area downtown. It looks very much, it is more or less a tramway. Going out of downtown, it goes out to the main line railway system, and then meets at some station cross-platform to the long-distance railways. So a seamless transport system throughout an area, a very large area, integrated service. So these people in Karlsruhe were the first to develop that. Of course, it must be mentioned, the boss of the Dr. Ludwig at Karlsruhe, he was very enthusiastic of pushing that type of system, and he had, of course, to fight with railways, with German ministries, to get this system working. Of course, there is a lot of legislative and regulatory and safety issues which need to be considered. Of course, a driver, here it is a training, has to be certified for tramway and long-distance railways, which is two different legislations. I mean, there's a lot of organizational issues which need to be met before you can operate a system like this. But to the customer, it's very convenient. So finally, the latest example is Hamburg, where we have since long a S-Bahn system, a commuter system, which goes through the city on two trunk lines and goes again to the outskirts here. This is a rather small DC-operated S-Bahn or suburban system with short distances in between and out there, longer distances between stations. The total network is 144 kilometers only. 113 are operated under 1,200 volts. And recently, since the year 2007, at this station, which was a terminal there, there was the introduction of such dual voltage trains, or the modification of the existing fleet, has allowed the S-Bahn trains to continue on federal railway systems for another 31 kilometers. But this one is only the first step. So the possibility